Good morning and welcome to this video for the 2020 Level 3 integration paper for Level 3 Calculus. So for question 1, we want to find the integral of x plus 2 plus 3 over x dx. So for x plus 2, we can just use the power rule. So we're going to increase the power by 1 and divide by the new power. So the integral of x plus 2 plus 3 over x dx, that's going to give us x squared over 2 plus 2x, and 1 over x integrates to ln of x, but it's 3 over x, so you multiply by 3 on the outside, so you plus 3 ln of x, and don't forget the constant of integration plus c. And this should just be an achieved level question. Question B, for t is greater than or equal to 0, the velocity of an object is given by v of t equals to 0.6 square root of t, where v is the velocity of an object in centimeters per second, t is the time in seconds from the start of the object's motion. The object has a displacement of 5 centimeters at t equals to 0. So what is the displacement of the object after 16 seconds? So for this question, we're going to be remembering back to our level 2 kinematics, so our a, v, and s. So to go from a velocity function to our distance function, we got to integrate, okay? Which makes sense since this is an integration paper. So we got s of t equals to the integral of 0.6 square root of t dt. We know square root of t is the same as saying t to the power 1/2, so we'll rewrite s of t as the integral of 0.6 t to the power 1/2 dt. And now we can just use the power rule, so we're going to increase the power by 1 and we're going to divide by the new power. So s of t is going to be 0.6 divided by 3 over 2, which is 1.5. And we're going to increase the power by 1, which is 3 over 2. And don't forget the constant of integration plus c. If we simplify this a little bit, we should find 0. Alright, so this should give us s of t equals to 0.4 times t to the power 3 over 2 plus c. So we know that when t equals 0, our displacement was 5 centimeters. So we can use that to find our c value. So 5 equals to 0.4 times 0 to the power of 3 over 2 plus c. So therefore c equals to 5. And therefore, after 16 seconds, we'll plug in t equals to 16. So s of 16 equals to 0.4 times 16 to the power 3 over 2 plus 5. 5 plus 5. So 16 to the power. Alright, so this should give us a final answer of 30.6 meters, not meters, centimeters. That should be our final answer for this question, and this should be another achieved level question. Question C, find the indefinite integral from x equals to 8 to x equals to 4 of 5x minus 11 all over x minus 3 dx. So for this question, you can't really integrate straight away since you have x on the numerator and x on the denominator. But we can simplify this and split this into two different terms by using a long division. So if we make 5x minus 11 divided by x minus 3. So you want to get rid of the x. So if we put 5 as our divisor, we'll have 5x minus 15. 5x minus 5x is 0. And we have negative 11 minus 15 is plus 4. So we can rewrite 5x minus 11 over x minus 3. That's the same as saying 5 plus 4 over x minus 3. So now this question is asking us to find indefinite integral of 5 plus 4 over x minus 3 dx. So we can just use our integration here. So we say that 5 integrates to 5x. And our 1 over x minus 3, since it's just x minus 3, the derivative of x minus 3 is just 1. So therefore, this will just be plus 4 ln of x minus 3. Alright, and that's equals to this. Alright, so now we can say that 5 times 8 plus 4 ln of 5 minus 20 plus 4 ln of 1 will give us our answer. So if we just use a bit of calculator rules, we should find 5 times 8 is 40 minus 20, that's just 20. 4 ln of 5 plus negative 4 ln of 1, ln of 1 is 0. So this just simplifies to plus 4 ln of 5. So if we want to write that in decimal form, we would just should get the answer of 26.44. That should be our final answer for this question, 26.44. This should be a merit level question. And to get an achieved, we should be looking at for an achieved, correct integration should get you an achieved. So up to this point there. Question D, graph below shows the curve y equals to x plus 3 over x and the line y equals to 4. Find the shaded area. Alright, so for this question, we need to find the two intercepts, so that the areas where the graph touches the line y equals to 4. And then we can take the indefinite integral from these two intercepts, okay, and we can use that to find the area. So first we've got to find these two intercepts, so we say that x plus 3 over x equals to 4. So x plus 3 over x minus 4 equals to 0. So now if we multiply everything by x, we'll get x squared minus 4x plus 3 equals to 0. And that gives us x minus 3, x minus 1, that equals to 0. Therefore x equals to 3 and x equals to 1. Alright, so those are our intercepts. So we have 3 and 1 here. And now we're trying to find the area that's below the line of y equals to 4, and that's enclosed by y equals to 4 and y equals to x plus 3 over x. So our area will just be the indefinite integral from x equals to 3 to x equals to 1 of 4 minus our x plus 3 over x dx. So therefore area equals to n 3 over 1. So if we simplify this, we get 4 minus x minus 3 over x dx. And now we can integrate, so area equals to integral of 4 is 4x, integral of negative x is negative x squared over 2, minus 3 ln of x. Alright, so area equals 2, so we just need to plug our values in. So 4 times 3 minus 3 squared is just 9 over 2, minus 3 ln of 3, minus 4 times 1 minus 1 over 2, minus 3 ln of 1. Okay, so we should be getting area equals 2, so I have 12 minus 9 over 2 minus 4 plus 0.5. That gives us 4 minus 3 ln of 3. So 4. And that should give us an area of 0.704 units squared. And that should be our final answer for this question. This should be a merit level question. To get an achieved, if you can get up to the correct integration, you should be getting an achieved. Question E, consider the differential equation tan x dy over dx equals the secant squared x over y when x is between pi over 2 and 0. Given that y equals to 2 when x equals to pi over 4, find the values of y when x equals to pi over 3. Right, so this is a separable differential equation, so we're going to separate it so that we have x on one side and then y on the other. So in this case, we can multiply both sides by y and divide both sides by 10x. So we get y. So we'll get y dy over dx equals to secant squared x over 10x. And we can say that the integral of y with respect to y, which equals to the integral of secant squared x over tan x with respect to x. Alright, so the left-hand side here is very easy since we can just use the power rule, so that gives us y squared over 2 equals to the integral of secant squared x over tan x. Alright, so in this case we can see that secant squared x is the derivative of tan x, and we should know that ln of, so basically if we have, so if we're trying to find the integral of, for example, f dash of x over f of x, then this will just give us ln of f of x plus c. So in this case, you can see that secant squared x is indeed the secant squared x is indeed the derivative of tan x. So therefore, we can just say that the integral of secant squared x over tan x is just ln of tan x. And we can actually verify this, so we say ln of tan x. So if we want to differentiate ln, so we say f of x equals to ln of tan x. If we want to differentiate that, we'll get the derivative of the inner function, which is secant squared x, divided by the everything on the inside, which is tan x. So that indeed gives us secant squared x over tan x. But if you don't see that, okay, so that's one way you could do it. But if you did not see that way, we can just do it another way. We can say let u be equal to tan x, okay? So therefore du over dx equals to secant squared x. And therefore we can say that dx equals to du over secant squared x. So we can rewrite this as secant squared x over tan x times du over secant squared x. We can cancel those ones out. So we'll just have integral of 1 over tan x with respect to u. But since u equals to tan x, this is the integral of 1 over u du, which equals to ln of u plus c, which equals to ln of tan x plus c, which is the exact same result we got before. So that's another way you could have done that integral, but either way, you should be getting the exact same answer, which is ln of tan x. Alright, so we should be getting ln of tan x as our answer, so we will write that one down. Okay, so we show that y squared over 2 equals to ln of tan x plus c. And therefore, okay, we can find our c value by plugging in these initial values. So we know that y equals to 2 when x equals to pi over 4, sorry. So 2 squared over 2 equals to ln of tan of pi over 4 plus c. Tan pi over 4 is just 1, ln of 1 is 0. So therefore that's just 0. And 2 squared is 4 over 2 is 2. Therefore c equals to 2. So therefore y squared over 2 equals to ln of tan x plus 2. Y squared therefore equals to 2 ln of tan x plus 4. Alright, so now we need to find the values of y when x equals to pi over 3. So therefore y squared equals to 2 ln of tan pi over 3 plus 4. We just need to use our calculator here, so tan of... Alright, so we should be getting y squared equals to 5.099. Therefore, if we take the square root on both sides, we should get y equals to plus or minus square root of 5.099. And that should give us y equals to plus or minus 2.258. That's our final answer for this question. It's plus or minus since if we take the square root on both sides, we'll get the plus or minus values. So y equals to plus or minus 2.258. That's our final answer for this question. This should be an excellence level question if you can get the final answer, y equals to plus or minus 2.258. A merit should come when you can find the initial value when c equals to 2. So finding c equals to 2 should be enough for a merit. Correct integral on both sides should get you an achieved. So getting up to there should get you an achieved. Question 2. Find the integral of pi minus 2 over x squared. So when you see the pi, it's just a constant. It's just the same as like 5, 6. It's the exact same thing. So when you integrate it, you just need to add the x. So if you find the integral of pi minus 2 over x squared dx, this will give us pi x. And if we rewrite, okay, we just get too far ahead of ourselves. Okay, so we can rewrite this as pi minus 2x to the power negative 2 dx. And we can just use the power rule in this case. We increase the power by 1 and we divide by the new power. So in this case, we'll get pi x, and negative 2 plus 1 is negative 1. Negative 2 divided by negative 1 is just positive 2. So that's plus 2 over x plus c. That's our final answer for this question, and this should be an achieved. Use the values given in the table to find an approximation to the integral from x equals to 3 to x equals to 0 of f of x dx using the Simpsons rule. So in this case, we can say that the Simpsons rule was... Alright, so Simpsons rule. So in this case, we can say the approximation of 3 f of x dx that equals to 0.5 over h over y0 plus yn plus 2 times of y1 plus y3, every odd one, and then plus 4 times of every even one, so y2 plus y2. Oh, sorry, that's the wrong way around. Should be should be 1/3 times h, my bad. So it should be h over 3. So in this case, we'll have integral of 3 0 f of x dx that equals to the h, which is just the intervals, the size of the intervals. The size of the intervals in this case is 0.5, so we have 0.5 over 3 plus of 1.1, which is the first value, plus 1 times of this last value, plus 2 times of every odd value, which is 1.8, plus 2.4, plus 1.8, plus 4 times of every even value, which is plus 2.1, plus 2.7. Alright, so quite a bit of calculator work here, so just getting the numbers in. So we have 2.1 plus 2 times of 1 plus 1.1, oops, 31.2 oh no, dang it, sorry guys, so just hold up a second, apologize for the long wait. 2.4. Oh, this thing is not working. 19 plus 2 times 1. Alright, there we go. That took a while. I apologize. So we should be getting our answer is 5.6. That's our answer for this question. This should be an achieved question. Apologize for the long wait there. Question C. Find the value of k, such as the indefinite integral from x equals to k to x equals to 1 of 9 times square root of 3x minus 2 dx equals to 126. So we need to find the integral of 9 times square root of 3x minus 2. So we just write that one down. So k to 1 square root of. Right, so for this question, we can just use our we can use a substitution. So we can say let u be equal to everything inside the square root. So when you see like these square root questions, it's always wise to let u be equal to everything that's inside the square root. So that makes life a lot easier. So we said let u be equal to 3x plus 2. Du dx is 3. And therefore, if we say that dx equals to du over 3. So therefore, this will give us integral of 9 times square root of 3x minus 2 over 3 times du. So this will give us integral of 3 times square root of u du. So in this case, we just need to integrate. So we say that increase the power by 1 divided by the new power. So it becomes integral of 3 divided by 1.5 times u to the power 3 over 2. That's not integral, that's just equal to. So 3.2. So this should give us 2 times of 3x minus 2 to the power 3 over 2. And the boundaries were k to 1. And that equals to 126. Okay, so in this case, we'll have 2 times of 3k minus 2 to the power 3 over 2 minus 2 times of 1 times 3 over 2 equals to 126. So 126 plus 2, because 2 times 1 to the power 3 over 2 is negative 2. If we move that to the other side, we'll get plus 2. So we get 3k minus 2 to the power of 3 over 2. That equals to 128. So therefore 3k minus 2 to the power of 3 over 2, that equals to 64 if we divide on 2 on both sides. And if we take the power of 2 over 3 on both sides, we should get 60. Alright, so we should get 3k minus 2 equals to 16, my bad, 16. And therefore 3k equals to 18, and therefore k equals to 6. And that's our final answer for this question. This should be a merit level question. To get an achieved, if you can find the correct integration, that's an achieved. So achieved would be up to this step there. Question D. If dy over dx equals to square root of y times cos of 4x and y equals to 1 when x equals to pi over 8, find the value of y when x equals to pi over 4. Alright, so we have another separable differential equation. So in this case, we're going to separate our x and y variables onto both sides and then integrate on both sides. So we can divide both sides by square root of y. So we have 1 over square root of y dy equals to integral of cos of 4x dx. So 1 over square root of y is the same as saying integral of y to the power of negative 1/2 dy. That equals to the integral of cos is sine, and we need to divide by the inside function, because when you differentiate, you multiply by the inside function. So when you're going backwards, you have to divide by the inside function. So cos integrates to sine, so this will give us 1 over 4 sine of 4x plus c. And in terms of the left-hand side, we can just use the power rule. So we add 1 to the power, and we divide by the new power. Negative 1/2 plus 1 is positive 1/2. 1 divided by positive 1/2 is 2. So this will give us 2 square root of y equals to 1/4 sine of 4x plus c. We can find c by plugging in this initial value, y equals to 1 when x equals to pi over 8. So 2 root 1 equals to 1 over 4 sine of 4x, which is pi over 2 plus c. Alright, so we know that sine pi over 2 is 1, so this will give us 2 equals to 1 over 4 times of 1 plus c, so therefore c equals to 7 over 4. So we should get 2 root y equals to 1/4 sine of sine of 4x plus 7 over 4. So we need to find the value of y when x equals to pi over 4. So therefore, you can say that 2 square root of y equals to 1 over 4 sine of pi plus 7 over 4. Sine of pi is 0, so therefore if we divide on 2 on both sides, we'll get square root of y equals to 7 over 8. And if we square both sides, we should get y equals to 49 over 64. 49 over 64. That is approximately, as a decimal, is 0.766. And that's our final answer for this question. This is again a merit level question, and you can get an achieved by finding the correct integral on both sides. So correct integral on both sides will get you an achieved. So up to this step here has an achieved. Question E, the graph below shows the curve y equals to x plus 2 root x minus 3. Find the shaded area. Alright, so this question, once again, is very similar to the question we were doing, which was, I think it was 1D. 1D, very similar question. We need to find the boundaries, so that's this boundary here and this, only this boundary, okay. So we only need to find that boundary there. So we need to make y equals to x plus 2 root x minus 3 equal to 0. So x plus 2 root x minus 3 equal to 0. So as you can see here, this is very convenient because we have x to the power of 1 plus 2x to the power of 1/2 minus 3. We see that x is directly equal to square root of x squared. So therefore we can, this is actually a hidden quadratic. We can say let let r be equal to x to the power of 1/2. And therefore we can rewrite this as r squared plus 2r minus 3 equals to 0. And therefore r, we can factorize this one out. So we have r plus 3, and we have r minus 2. Not minus 2, minus 1, sorry. That equals to 0. So therefore r equals to 1 or r equals to negative 3. I mean, obviously r does not equal to negative 3 because it's on the positive side of the axis. And also we know that we also know r cannot be equal to negative 3 because square root of x equals to r, square root of x equals to r. So therefore, if we say that square root of x equals to negative 3, that's not possible since the square root of any number has to be a positive. So that's not possible either. So therefore, we say that square root of x equals to 1. Therefore, x equals to 1. So that's our boundary. That's x equals to 1 there. So now we just need to find the area. Okay, so now the question becomes very simple because now all we're finding the area from 4 to 1 minus the area, minus the integral from x equals to 1 to x equals to 0. The reason that I say it's minus is because the graph is below the x-axis, meaning that the definite integral will come out to be a negative number. Because we're finding the area, we need to consider it as a positive. So we take a negative of a negative number. That's going to give us the positive value. So what it's actually going to look like is that the area total, that's what we're going to call it, that equals to the integral of 4 to 1 of x plus 2 root x minus 3 dx, and minus the indefinite integral from x equals to 1 to x equals to 0 of x plus 2 root x minus 3 dx. That's a minus. Alright, so first things first, we've got to integrate. So integration here is very simple because we just have x and square root of x. So x squared over 2 plus of 2 over 1.5 times x to the power 3 over 2 minus 3x to the 4, 1 minus the same thing. Okay, so now we just need to do a little bit of calculator work, okay? Just be careful at this part. So 2... Alright, so we should get 4 squared is 16, so 8 plus 4 over 3 times 4 to the power 3 over 2. 4 to the power 3 over 2, what's that one? That should be 16 if I'm not mistaken. So 4 to the power of 3 over 2. No, that's 8, my bad. Okay, that's 8 minus 12. Minus of x squared, 1 squared is 1/2, plus of 4 over 3 times of 1 minus 3. Minus, okay, so we just do this first. So we should get 8 4 over 3 times 8 plus 8 is 12 minus 0.5 minus 4 plus. Right, okay. I think I'm getting the answer of 7.83 here. So this equals 7.83 units squared. And we need to do negative of the integral of x equals to x from x equals to 1 to x equals 0 of the same graph. So that one should give us a 1 over 2 plus 4 over 3 times 1 minus 3. But it's a negative there, so forget that. So we have 1 over 2. That should give us an answer of 1.17 units squared. So if we add them together, we'll get the total area. So total equals to 7.83 plus 1.17. And that should give us an answer of 9 units squared. That's our final answer for this question. This is an excellent level question. To get a merit, I think you need to be able to find the integral from the correct integrals, correct boundaries. So up to this step here should get you a merit. To get an achieved, if you can, not too sure for an achieved to be honest, but for an achieved, typically if you can, perhaps even if you can do this step, you might be able to get it achieved, but I'm not too sure. Not too sure about it. So question 3, find the integral of secant 2x tan 2x dx. So we should find that the integral of secant 2x tan 2x on the formula sheet is just 1/2 of secant 2x, okay? So this gives us, because secant tan will integrate back to secant, so in this case we'll have 1/2 of secant 2x plus c.